All right, here's my thinking on 20.3, your turn question from the topic 20 reading. So what we have here is a reaction. It's a titration. We're titrating hydrogen peroxide and potassium permanganate solutions. The potassium permanganate solutions in the beaker and the hydrogen peroxide solutions in the burette. And we're titrating to the endpoint, and the endpoint is reached at 34.05 milliliters of hydrogen peroxide being added to the 25 milliliters of potassium permanganate. But before doing this, the description of the solution that was made was described. So they took 20.65 grams of potassium permanganate solid and they added it to enough water to make a 500 ml solution. And the first question asks, what's the molarity of this potassium permanganate solution? So the first thing that we're going to do here is we're going to change 20.65 grams into moles. So we're going to have to divide by the molar mass. So 20.65 grams of potassium permanganate, 1 mole of potassium permanganate. That I do not know. So let's use the periodic table here to figure that out. Alright, so we have a potassium at 39.1. We have a manganese at 54.9. And we have 4 oxygens, 16 apiece, times 4 is 64. All right, so that gives me a molar mass of 158 grams. So 158 grams. So 20.65 divided by 158. We'll call it 3 sig fig. So I got 0.131 moles. All right, and then what? We have a 500 ml solution, so we're going to take our moles and divide by our volume, which is 0.5 liters. So 0.131 divided by 0.5 is 0.262. So 0.262 molarity is what I have for A. B. For B, they want us to write out the balanced chemical equation for the redox reaction. So the way that we can do this is we just go up to these half reactions they gave us. So here's our oxidation half reaction, where the hydrogen peroxide is losing 2 electrons, and then here's our reduction, where the potassium permanganate's gaining 5 electrons. Well, you can't lose 2 electrons and gain 5. So these electrons have to be balanced out. And the common multiple there is 10. So I'm going to multiply everything by 5 here to get my electrons to be 10. And then I'm going to multiply everything by 2 here to get my electrons to be 10. So there's that. Okay, now I'm just going to add these reactions. So my 10 electrons cancel. So your electrons should always cancel when you take 2 half reactions and add them. If you look at your hydrogens here, your 10 hydrogen ions here are going to cancel out 10 of these. So you're going to be left with 6 hydrogen ions. And I don't see anything else canceling. So our overall reaction is 5 hydrogen peroxides plus 6 hydrogen ions plus 2 permanganate ions. Again, the potassium's not there because it's a spectator ion, so that's why you don't see potassium. What do we have? 8 waters, 5 oxygen molecules, and 2 manganese ions. So there's your overall balanced equation. So that's B. C says determine the concentration of the hydrogen peroxide solution. So, well, we know the molarity of the potassium permanganate solution, right? That was in the beaker. And we know that we added 34.05 milliliters of hydrogen peroxide to reach the end point. So that means, based on our equation here, the potassium permanganate that's in our beaker here has a ratio of 2 moles of permanganate for every 5 moles of hydrogen peroxide. So what we should do then is we should figure out the moles of hydrogen peroxide. Actually, what we can do is we can figure out the moles of permanganate that was in the beaker. And I think we know that from right here. So we had 0.131 moles of permanganate ions floating around in our beaker. And that has been completely reacted. So what we can do here to figure out C is we can take our 0.131 moles of our permanganate. Again, potassium's gone because it's a spectator. I mean, it's not really gone. It's just floating around. It's not reacting. And then what we can do is we can say, all right, if we have 0.131 moles of permanganate that was floating around in the beaker, and we have a ratio of 5 hydrogen peroxide moles for every 2 permanganate moles, then we can figure out the amount of moles of hydrogen peroxide that we had to add. So 0.131 times 5 divided by 2. So that gives me 3 sig figs, 0.328 moles of hydrogen peroxide needed to be added to completely react the 0.131 moles of permanganate ions. So, but they want concentration, so then we're going to have to take this and we're going to have to divide by the volume that was added in liters. So I'm going to divide this by 1,000. So our 34.05 divided by 1,000 is what, 0.0341 liters. And I'm just going to divide that out. So 0.328 divided by 0.0341. So I got a concentration of 9.62 molarity for the hydrogen peroxide. So that's C. D says calculate the grams of hydrogen peroxide used in the experiment. Okay, well, we can do that. They want the mass. So they want the mass of the hydrogen peroxide. Well, what do we know? We know the molarity. We know moles. We know the moles that was used. And okay, so we can do it. We can just multiply by the molar mass, right? So if we know the moles, 0.328 moles of hydrogen peroxide, and they want grams, we just multiply by the molar mass. The molar mass of hydrogen peroxide, 16 for oxygen times 2 is 32, plus 2 is 34. It's 34 grams per mole. So 0.328 times 34. I'm just going to keep this at 3 sig figs. 11.2 grams of hydrogen peroxide were used. And then E wants the percent of hydrogen peroxide in the solution. Okay, well, they gave us the density way at the beginning of this question. They said the density of hydrogen peroxide is 1.05 grams per milliliter. And now we have the grams. So if the density, which is mass over volume, if the density is 1.05 grams per milliliter, and that's equal to the mass, which is 11.2 grams, and the milliliters that we used were 34.05. Hang on, what am I doing wrong? No, I'm sorry. We're going to figure out the mass. This is the solution. We're going to figure out the mass of the solution by doing the density and the volume. So I'm going to multiply 34.05 times 1.05 to get the mass of the solution. 1.05 times 34.05. Okay, so the mass of the solution was 35.8 grams. The mass of the hydrogen peroxide is 11.2. So if we want to know the concentration of the hydrogen peroxide, we'll just divide the two. So the percent of hydrogen peroxide in the solution is going to be 11.2 divided by 35.8 grams. Again, mass of the hydrogen peroxide itself divided by the mass of the solution. Looks like about 30% divided by 35.8. Yeah, 31.3%. And I think that's it. So that was 20.3. Definitely a lot more involved than the first two questions. So I'll cut it short here. I'll make a separate video for 20.4.